make it better. You need to be louder.
Is it better?
Yeah, much better.
Thank you. Yeah, I'm Bhaskar Durai. I work for Autonomous as an enterprise security architect. I have Balaji Ganeshan. He also works for Autonomous as an enterprise security strategist. We both come from XA Secure. Those who are not aware of XA Secure, we used to do fine-grained authorization, centralized policy administration, and centralized audit for the Hadoop ecosystem. And last month, in May 2014, Autonomous acquired us with a commitment to open source the product. So last month, we did a proposal to Apache for an incubation project called Apache Argus, which got approved. And last week, we open sourced our code, and now it's been committed to the Apache Git. So today, I will give an overview of Apache Argus, and also give the current landscape of security with respect to Hadoop. We'll share some of the vision of Apache Argus, some of the current features, and the architecture and the smart demo. The goal of Apache Argus is to give a comprehensive solution for the security in Hadoop. If you take security as of today in Hadoop, it's extremely complex because you have first of all, the entire deployment is distributed. Secondly, you have more than 27 components which coexist in the ecosystem. They communicate with each other. They are dependent on each other. So when you want to configure all these components to work together uniformly with the same security concept, it becomes very challenging. Then as you take enterprises, as they are adopting more and more Hadoop, they are facing security as one of the biggest challenge. So the vision of the vision of Apache Argus is to address all the security issues that are in Hadoop, and at the same time make it easier to install, manage, and monitor it. The approach that we are taking is a top-down approach. What we want to do is to build a security framework where you can easily go and configure all the policies, manage it, and monitor it from one place. So for doing that, what we have done is we have built sort of a framework where we store the policies all in a central place, and those policies are pushed down to individual components, and this components does the enforcement. And while these components are doing the enforcement, they also collect all the local audit events and send it to the centralized server so that you can now do the processing analytics on the auditing from the central place. So once we have this uniform layer, then it's much easier to have a different type of UIs on top of it, or you can publish APIs. So if there's a third-party tool who wants to configure any policies, I want to view the policies, and they can do it very seamlessly. Now what happens is that each and every component, as you've seen in Hive, they have their own policy management, and you have to go and talk with each one of them. It becomes extremely challenging. So once we have a centralized framework, then any partner, any enterprise can just talk to one single entity to do all the work. While we are doing it, we also want to do a very tight integration with the individual products, like Hive and other edge-based. We want to make sure that we work with them together to define the interfaces very well. So if we can abstract all the key security components, that is authorization, authentication, encryption, or auditing, then we can easily replace the existing one with their favorite provider. Because in enterprise, everyone has different requirements. Some may be okay with giving a full file permission, but someone may need much more fine-grained authorization at the column level. So they can pick and choose what they like to do. So this is the current state of Argus with respect to the Hadoop framework. If we take the four security pillars, like authentication, authorization, audit, and data protection, we sort of play a bit of a role in each and every one of them. If you take authentication, Kerberos is the de facto standard as of today, and we don't want to change it. But it's extremely painful, particularly when the enterprises don't have the necessary skill set to deploy Kerberos or manage or provision all that. So as you're adding more and more components and there are more and more data nodes that are added, you have to go and do the provisioning, so it becomes painful. Even communication between components is a big challenge when you have security enabled. So what we want to do is make sure that the provisioning and everything is made easy. Similarly, in authentication pillar, every enterprise, they have one or another single sign-on. So when you log into a particular website within the corporate environment and you go to another website, automatically the credentials or the tokens are transferred. So you don't have to relog in. So when you put Hadoop and if you want to access any of the web interface, we want to make sure these applications, they cooperate and they work within the same framework. So we want to make it pluggable enough that you could make it work with any standard or sign-ons like Oracle Access Manager, Cycler, anything like that. And most probably we'll also try to come something out of the box. So if you don't have a corporate one, even within the framework, you don't have to sign multiple times. Then coming to authorization, XSAQ was primarily focused on authorization audit. So we have done a lot of work in these two areas. So if we just pick authorization, it's a pretty complex topic. If you break it down into two pieces, one is the data access and second is the access for operations. The data access itself, if we start going into it as we looked into the Hive, there are many different ways of accessing the data. The data may be stored in one way, may be accessed in multiple ways. So as you start trying to configure it, you get into a lot of these complications of different components and how you want to make sure they all work together. So example, in HDFS, you can access the file as a file. The same file can be accessed to a Hive as a query. Now, in HBase, you do get and put. And now you start taking Kafka, if you take Solar, they have different use cases, but they all deal with data. So in Kafka, you can publish or consume from a topic. So you want to make sure who can publish and who can consume, because you don't want data to leak from that. In Solar, you're going to getting data from many different data sources and indexing in the central place. Now, once you do that, what about security? Who can actually, if I cannot just do a query and get the data from third data source, like a Solar, because they have their own data management. So, if you go on the authorization, on the operation side, if you need to make sure that who can start and stop a service. If you want to add a data node, you want to make sure the authorized users can add a data node, delete a data node, or suspend a data node. Otherwise, anyone can go into some dimension. Then even if you take service, you will need a more fine-grained operation access control. Like if you take Storm as a concept of topology. So you want to make sure who can suspend the topology and who can resume it. Okay. So those are the areas that come into authorization. Right now, Apache Argus, we support HDFS, Hive, HBase. The next release, which is coming in the next 1 or 2 months, we will be supporting Storm and Nox. And the goal is to support almost all the components within the audit framework. Now, coming to audit, almost every enterprise has some requirement for auditing, whether it is compliance driven or it could be some other things. Like there are PCI compliance for credit card, for healthcare, PHI, and there's various privacy compliance for PII information. So all of them has to be audited. In the Hadoop, since you have so many different components, and most of the components right now, during the audit log, it actually goes to a file system. And you have to collect all of them and do some processing. And with Yarn, it becomes much more difficult because you may spawn a process in real time and bring it down and you'll just lose all the audit records. So it's important that somehow you have to gather it in a more reliable way and at least send it to a central place. So what we do in Apache Argus is, at least for the component that we support right now, we collect all the audit logs and send it to a central server or database. And from that database, you can do any sort of a reporting, whether it is searching based on who has accessed a particular component, or pick a user and see what are the accesses they did across different components. And another thing is also policy. So as we are adding policy and removing policy, you have to make sure that those are audited. In Hadoop today, most of the policies, other than the top tier components, they are in XML file and other configuration file. So if anyone wants access to the box as the user access, they can go and modify it, and there's no traceability. So having it in a centralized administration way, you can manage the policies and make sure who's authorized to do it and audit it also. The fourth is the data protection, which is encryption. Encryption falls in two categories. One is on the wire encryption. The second is data encryption at rest. Hadoop has done a good job on that side because almost all components they now participate in SSL, and if you really want, you can make it secure. On the data at rest, if you want to do volume level encryption, there are lots which are free software in Linux. You can just encrypt the entire file system just like you would have done on your Mac. And if you want a little bit more, better than that, you want to encrypt your folder or file. There's a new HDFS Jira that has been going on, which will give you the option to encrypt folders or files. And some of the enterprises, particularly in healthcare, they also want much more fine-grained authorization encryption, where they want to encrypt columns or fields in a file. So those are the areas we are trying to work with the component owner and see whether we can give that level of flexibility. There's another thing in encryption that is two other things. One is the cipher strength algorithm, and second is the key management. This is also very important. So when it comes to an enterprise, we want to make sure that you can consistently follow the same policy across each and every component. So if there are more than one component doing encryption, we want to make sure that they use the same key management system, the same algorithm, because some of them are required by regulation. So once we have the centralized policy management, then it's not just about authorization. You can just make sure that all of these policies are pushed across all of them and also audited and very consistent. Then the last piece is the centralized security administration. So what we have done is we have a portal, it's a UI portal which actually you can go and now configure all the policies from one place. Whether it's HDFS, HBase, hard, now, strong, you can just come and do one place. The advantage is now you don't have to go to all these individual components and tweak it or manage it. Because everyone has their own way of doing it. As I said, somebody just have XML files or JSON files. The other advantage of having a centralized security administration is if you take the way the enterprise or everyone is moving is going towards a single cluster, a data lake. And now multiple line of business, they're trying to put their data in one cluster. Now you have to make sure that you have to provide a decent multi-tenancy ability. Otherwise, you could go and manage anyone's SS policies. So what we have done is we have given a multi-level, multi-tenancy or delegated administration. You can pick a given resource, and which could be a folder or a table, and you can give permission to some other users to manage it. So you can then monitor who is giving permission and also audit that. Okay. So this is my last slide before I go for the demo. Okay.
So you talked about the compliance issues, right, in the previous slide, and you talked about the data lake aspect also, which is great. This is exactly what financial companies and healthcare companies are doing. But with the data lake, there is also the problem of PCI or PHI data coming in, with the different business units bringing in different sources of data. Possibly one team might land up bringing in some PCI or PHI, which will break the compliance, which is a nightmare for the CIO. So, do you have any sort of compliance when you say you're helping out with the compliance? Do you have any tools that sort of audit and keep a watch on that kind of aspect, or this is more of who did what? That's the only thing.
So this is a good point. So the audit right now, we are doing primarily user access. Right? And we are doing user access, we are also auditing who has changed the policies and everything. But the goal is not just to stay with that, it's also audit everything, including when in the previous security environment, there could be other components, other vendor who could be doing primarily PCI related thing. If they send the audit record to the centralized one, then we can do the reporting and we can see it in one place. So particularly for PCI is pretty straightforward. They have very strict rules. Who can, what's the strength of the key, and who can decrypt it, and where it can be decrypted. So So but when it comes to PHI and PII, you can have the raw, the clear text in the same environment, depending upon how the credits could be as simple as just it should be encrypted. So there are other components within the Hadoop framework like Falcon and all that, is primarily dealing with the governance, and Linux, that's where we come into play and help them do the policies around it, so that they can enforce it. So coming to the architecture, we have tried to keep it pretty simple. So it's like 2 layers. On the top level, we have the administration layer where you have all the policies, everything defined, we store it, and that's also where we all our auditing stays. The second layer is what we have is something called a plugin architecture. So our plugins are very, very lightweight, literally Java libraries, less than like 400K. They run within the process of each and every component. So it's not a separate process. So they're pretty much like tied within it. Now, as you're doing all your authorization within this Hive or this HDFS or HBase, we are in the path and we override the authorization. So we can enforce more than what the native can do. So some of the simple example was column level encryption. Column level access control. If you have iServer 2, the native one may not support it, but we do support it. And we can also support like more than that, and we can support wildcards and other things. So it opens up the ability to extend the native one. And while we are doing it, we are also making sure the same concept philosophy is applied for all the components. So now we can apply a wildcard or other things in HDFS and HBase and any other component we support. Yeah.
Most a quick question. So I'm assuming the plugin is going into all region servers, all data nodes.
Exactly. Yeah.
Not data nodes.
Yeah, so not the data node. Right now we only need a name node.
Okay.
Where the authorization is, depending upon what activities, generally on the data node there's not a lot of activity done. So wherever you need activity, we'll do it. But the Ambala is correct.
But for HBase, it will go to all region servers.
For HBase, we go to all region servers. Yes. The 3 things the plugins do. The first thing it does is it actually pulls in all the policies from the central server. So there's no dependency with the policy server as it is running. So there's no single point of failure. Second it does is it does the enforcement. So in the case of Hive, as Tejas mentioned, so we override the default plugin, the API, and we put our plugin implementation in it. So we do the enforcement. The third is auditing. So all the audit emails that are collected at real time, we're actually sending it to the centralized location so that it can be processed. So that's why even if the process goes on, we still have the audit record available.
What is the audit server?
So audit server is essentially right now in this particular release, it is our RDBMS, and we have the administration server which does all the queries on top of it.
So if you want to scale that, like what would you build it into, like a Hive warehouse or something like that?
So right now in the next release, which is coming the next 2 months, we're going to be putting into HDFS.
Okay.
So that you can have Hive on top of it, but the architecture is going to be pretty open enough that now you can actually move to a Kafka. So from the Kafka you can send it to Solar for indexing, HBase for storing, Hive for so all those capabilities will be open up.
Kafka itself is not secure though, so everybody.
So actually we are working on the Kafka side also.
Okay.
So we will be making sure that the topics and everything is also access control. So let me go through the demo quickly, then we can open up for questions. Let me see. Okay. So this is our central policy administration invoice application. So from this place you can actually manage the policies for all the components. And since it's centralized, it's not tied with any single cluster. You may have multiple clusters in your environment. You may have multiple databases or multiple topologies for NARCs or STROM, doesn't matter. You can have just one administration portal to manage all of them. So if I take HDFS, let me take one simple one. So the way we are doing a little bit different than what the traditional components will do, because one of the goals is to make sure that we are consistent across all the components. So we don't want to really make it exactly what we do, except for 2 things. One is our the permissions still come from the native component. We want to make sure that is consistent because we don't want to add and remove things what we are already providing. And secondly, the resource is also what the component will be managing. So in the case of HDFS, it's all about files and folders. So here it is all files. So what we have done is you can actually have as many resources as you want to in one policy. If you have a logs, you're going like 10 different places, you can have it all out here. You can use recursive, you can use wildcards, and we give you options to, you can just, we do a lookup automatically, and you can add as many as you want to. I can just give something like that. So what happens is any files with application, then this policy will apply for that. So this makes it easier for you to write. You don't have to go and give permission for each and every file or folder within the HDFS because that moves the next one. Okay. Then the second is groups. So even before Hadoop HDFS added their multi-group support, we had it in our strings. So you can, if you want to give marketing read permission or read permission, you can just give it out here. If you want to give another group write permission, just going to do something like this. So you can use the permission out here. So you can have various combinations in one place. So it makes it easier. So if you have a group and you want, let's say the network group has more than one users, and you want to give some special permission to one user, you can have an exception for that particular user itself. And let's assume I want to give an administration privilege. What this really means is now this network, one user can log in, and for the resource that is given below, they can do delegation. So that means they can give policies for other users. So you don't want to have one central administrator trying to do the policy for everyone. So you can have as many administrators as you want to. You can go at the level of file level and say, okay, this file I'm going to give administration access to one person. So it's all possible. So it just scales up.
This would be similar to how HDFS cycles would work?
It is similar to?
HDFS cycles?
So we override the HDFS cycle.
You would, okay.
There's a little bit of a difference in the HDFS cycle only, but other than in other components we override. The advantage of it here is we have the ability to override it. In the case of HDFS, what we do is we do ours first, and then we pass it on to HDFS if we disallow. And then we let HDFS make the final call. The reason is in the real world, people have done so many policies and we don't want to break them day one. So eventually we'll recommend them to move to 100% RS and disable the HDFS altogether. Just a flag actually, you can turn it on and off. But for Ivan, it's basically by default is turned off. You override the policy. So similarly, even though by default audit logging is enabled, you can turn it off and selectively turn on and off. As I mentioned, every enterprise has their own requirement. If you're an enterprise or the enterprise needs to want to audit only sensitive folders, you can turn it on. So you have much less noise. Similarly, you could do the same thing for Hive. So Hive is a good example. Right? So Hive, the concept of resource is different. Here we're talking about database, tables, and columns. And if it is I server 2, then we can go up to the level of columns. You can set up pick certain columns and give different level of permissions. So as the question you were asking before, here you can actually do two set of users or different set of columns and you can do different level of permissions if you want.
Without creating views.
Without creating views. So yeah. So if you for us, there's no difference between views and tables, honestly, but yeah, without creating views, you can do it. So for the same table, you can do that. Okay. Then the permission set is also dictated by the Hive. So select, update, whatever they support. But the rest of them is the same. So the way you assign groups is the same as you would have done for HDFL. The same concept of admin is out here. So from the enterprise point of view, now you don't have to learn all the SQL-like syntaxes because it's not a scalable model. If you're only doing IL and you want to be SQL compliant, that's fine. But if you start adding more and more components, you want to make sure that you have a simple similar way of doing it. The same for edge base. Here we have families and columns. In the case of Knox, it's topologies and services. So, but everything else remains the same. In the case of Knox, we support IP. Going forward, since most of the code are the same, we can start supporting IP based for all the components also. So there's a common. So it's pretty easy to externalize and implement it outside the core component. So we don't have to worry about it. Okay, so let's do a quick demo, not demo, use case. So actually I'm logged in as marketing. So marketing doesn't have permission to CDR data. So let me see if I can go there. It's not in. So since our marketing doesn't have access to CDR data, immediately you can block. If you come to our audit, you can take a look at it. It is blocked. So this user marketing tried to access CDR and was denied. Let me do a quick one on high, then we talk a little more on the. Actually, let me go something. Let me go second to. You have to go to yes, access to customer. You can open this file. Okay, so let me go quickly to high. So I will do a query on the customer details page or table, and I'll pick a column that the marketing user doesn't have permission to.